Thank you, Teresa. So this is my honor to be here to represent our district to share some kind of the experience regarding how we can do the data locally. And then what's the ending user? In here, I kind of group like a 4 type of different ending user. One is the public and decision maker, analyst, and the scientist. Public, like my air district, we cover the 3 different air basins. So the first thing will be like in the public, when we see the smoke, for example, coming from wildfire, they will always got a call from the public ask, say, what's the air quality here? And are we good to go to the Tahoe area for migration? So that's kind of the public demand. We'll need to answer for that. The second one, the decision maker is like our board director. If we want to go to do the regulation, want to adopt or amend the regulation, what kind of reason why we didn't do that? And air quality data could be a good reason to tell them that's what we need to do for that. Analysts, like I say, the local jurisdiction, they have the land use project, and then they want to know if I build out this kind of big specific plan, so many houses we're putting here will be jeopardized the region to attain the federal standard or state standard. So that's how they will need to use the data to analyze for that. And the scientists will be use the air monitoring data to put into the model, for example, like Eric mentioned in the keynote, say you want to focus what kind of PM impact will coming from the prescribed fire, and that's how you need fit in the air quality data layer, so therefore can run the model to focus for that. So in here, I'm kind of share like 3 cases with just in from our air district, try to understand how we use for the data locally. First one is the public certificate, public demand, and like I say, we have the 3 different air basins. So most likely we'll get a call from the public want to know what air quality could be. It's good to go to the Tahoe area to travel. That's kind of information. And Spare the Air program, that's how we fit into the program for the region, so people understand today is a Spare the Air day, so therefore they probably can see how they can reduce their travel, commute travel, so try to spare the air. And then the other one is that we have the daily burn message, because we have 3 different air basins, so it could be a different meteorological condition, the geographic condition. So by the different air basins, we may have different requirement for the burn message. If you can burn, you cannot burn. Like especially like a Sacramento Valley air basin, we have the rice burning season. It would be good to burn, and how many acres you can burn. And then versus to like a Mountain County area for the residential burning, if today is a good day to burn, otherwise you could smoke your neighborhood. So that's kind of the things usually we do in daily for the public information. And also the data could be someone used for example, like the Central California air quality study to show how the ozone transportation could be, and that's how I identify my air district is like an upwind district to the San Joaquin, so we need to do some kind of regulation to consistent with them, able to reduce impact from them. Or like about like the American Lung Association State of the Air report, usually use their scoring system try to grade how good we are or how bad we are for the air quality. So this is kind of information. Our district, when we had a Wi-Fi smoke impact happen, and we activate this webpage to provide information for the smoke impact, and also instant air quality data from each site in our county. And then this is how we prepare once we had the fire, and we prepare to update our county health officer and also the Office of Education to see how that air quality could be. And you can see that the first one is the 3-hour average for the PM 2.5. The second one is like for the past 5 days, how the 24 hours average for that. And the really last one is for the past 24 hours when we issue. Like this one is on November 15th, when campfires happened, and we just provide this information to the county, and that's how they realize what the information could be. And then I think that would be kind of very unique. I mean, when the Spare the Air that day, you see that color layer, at least red, purple. So I hope we don't see that again, but who knows in the future. But that's kind of information we provide to the public. And then this is a burn message we're doing every day by the different air basin from our air district, use that air quality data PM measurement to try to determine if that would be a good day to burn. And then this is a Central California ozone study page, and this is the state of air, like 2018, how great the air quality for that. So that's for the public. Second one I share with the case is we had a small community called the Meadow Vista, eastern, probably like 10 miles eastern from Auburn for that. And then there's the asphalt concrete plant was there before, and they got a permit from us, but recently they just want to expand so they can provide the service for the repair, the I-80. So we don't have any issue for the permit, but they do have issue for the land use permit. So that's how county come out to work with us, say, is there any kind of impact from that traffic from the truck traffic from the asphalt plant, because the local community complained about the PM issue could be coming from the traffic. So that's how we set up kind of the station to collect 1 year data to see what it looks like. So this is the area for that Meta Vista where it is. It's a small community, probably like 3,000 people living there. And then that's our shed. We just sit there, do our best for that, for the two band. One is for PM10, one is for PM2.5 to collect the data for that. And then this is how kind of first thing we get the 1 year data. We separate from the winter and the summer to see how the pattern for that. And you can see in the winter time is higher than the summertime. And then by the hourly pattern. And usually you see if that be impacted by the traffic, you should see during the traffic hour you have the high impact, but it doesn't look like that way. So that's why we do the more detail of engage with some ambient temperature. And we see that kind of career say, when the temperature going up, and then the concentration going down for PM2.5. But then when the temperature going down, then PM2.5 going up by the hourly pattern. So that's how we kind of curious, okay, now we see in December, which is kind of winter time, and we suspect that could be not coming from the traffic, from the truck, could be coming from the local activity, which is maybe for the wood burning stove. I mean, that emission there. So we can see here, probably like 80% of the PM10 is PM2.5, and then very obviously opposite between the temperature and the concentration show, and the PM10 and PM2.5 track very closely. So that's how we brought up this to the community. Let them understand and say, well, that the traffic from the truck could also cause the PM impact because diesel particle maker, that's how they kind of concern for that. But maybe the more likely is a major contribution from the local, from the PM, could be coming from your local wood burning device. So this kind of information we bring back to our board and got the support to do the incentive program for the county-wide to do for 4 years and to provide incentive for the people if they want to retire a non-EPA certified device, then burn and then reinstall for the certified device or even like a natural gas fireplace for that. So therefore we provide incentive to them to help for that. So this is one after 10 years. You can see it's a change. Now still you can see that the concentration there, but compared to before, it's kind of changed. So that's how kind of we use the air quality data, share this case, use the air quality data to support like a regulatory decision from our board for that. And third one is we did the Roseville rail yard study in 2004. At the beginning is when the local complained about the locomotive diesel smell for that. So we kind of get the Air Resource Board to help us to do the risk assessment in 2004. And then after that, we identified kind of marble and show it could be potential risk there. So we come out for that, cooperate air monitoring project with the Region 9 Air Resource Board, Sacramento AQND, South Coast AQND, and UC Davis, Dr. Cahill group, and also there's a research institute. Try to figure out, say, once the model see that the risk number there, and it's really, we can see the concentration measurement there. And then maybe that data could be used to track, because that time, the Union Pacific signed an agreement with us, also want to do some kind of mitigation. They will say, they are going to reduce emission, but we may just try to see if possible the air monitoring data could able to help us to track if the emission will be reduced. So that's the rail study from ARB to doing for the rail yard 2004. And then that's how our station, we kind of do a 2 pair of the monitoring station, upwind, downwind. So theoretically, we're thinking if the differences between the upwind and downwind should be the emission coming from the rail yard itself. So that's kind of the theory for that. And then that's kind of result, and really you can see some differences there. Even, the instrument is kind of the low concentration measurement, and the instrument may have the detection limit, but we still can see the differences there. And that's a PM2.5. And then we also have the black carbon, which we use the accelerometer to show how the concentration will be, because that's how we use the black carbon as a surrogate to do for the diesel particle meter, which is one thing we kind of concerned about the locomotive emission there. So that's kind of information there. And after that, then after 3 years, I believe, 4 years of that, the agreement required them to provide a report to show how the emission will be reduced, how they're doing for that, so therefore the real emission there. And that's how we try to figure out, based on the monitoring data, do we really see the concentration going down? Even the equal, it would be still good, because then that's how you know, because at that time they have a lot of activity increase in the yard because the economics is in there. And then we want to know if I really see the trend going down or equal, so therefore we see it really happen for the emission reduction. And based on this comparison, you can see that the dotted line is what they report for the emission from the calculation, and the solid line is the monitoring data to show it's going down for that. So logically, we can see it's kind of the things we support for them to say they really reduce the emission. So yeah, that's a recap about what I'm talking about the air quality data we use in the local, and then that could be used for the public, opinion, what we want to know what air quality could be, or how that the research academic can use for the modeling run for that, and policy, how the decision maker can make a policy because we want to improve the air quality for that. But anything that it could be, the monitoring work could be very boring or probably a lot of documentation you do for that, because like my technician, every 10 days need to driving from Auburn to Tahoe for the site to maintain. It's like a 1.5 hour driving distance there, and then back here again. So that would be kind of very intensive. But it's because of the hard work for that, and that's how we got the good data, and we need to comply with all the requirement for that, regulation requirements. So have the good data, and then the good data can support to make the case. That's how we can provide to our decision makers to see how good we are and what kind of things we can do for that. So I hope we feel very important for us, because that's how the air monitoring data is the foundation to make the air pollution control meaningfully. Thank you. That will be my presentation. So